Hot! Hot! Hot!
Today, we're embarking on an exciting journey to stress test the latest flight tracking enclosure. To really turn up the heat, we've strategically placed the unit inside a shed, which has been simmering under the relentless Texas sun. The current temperature of the shed is 111 degrees Fahrenheit, and the Pi CPU is at 140 degrees Fahrenheit. The Pi is rated for temperatures of up to 85 Celsius or 185 degrees Fahrenheit. Here we have the Raspberry Pi unit, and to simulate a fan failure scenario, we've left it exposed with no fans running. Its metal construction turns the unit into a massive heat sink. This design is not just about durability, it's a deliberate test of the metal casing's capacity to dissipate heat without the aid of a fan. Now, let's transition to the next phase of our experiment. We'll place the Raspberry Pi unit inside the flight tracking enclosure, this time with the fans operational. Our goal is to observe the impact of active cooling on the unit's temperature. Just 5 minutes in, and we're already witnessing impressive results. The temperature of the Raspberry Pi's CPU has notably dropped to 123 degrees Fahrenheit. Meanwhile, inside the flight tracking enclosure still situated within the shed, the temperature has decreased to 105 degrees Fahrenheit. These early indicators suggest that our cooling strategy is working effectively, providing significant relief to the unit under stress. Fortunately, the unit is destined for a location known for its mild summers, which means the system will face less heat stress overall. This reduced thermal challenge should enhance the longevity and reliability of our setup, ensuring optimal performance in a less demanding environment. Stay tuned for future updates.